Okay, so now I want us to look at this question 7. This is acid and base. We're going to have so much fun working around this topic. So, this is question 7 of the May 2025 June question paper. And the first question says, define acid according to Arrhenius theory. So, what happens? What you need to ask yourself, what happens when an acid is dissolved in water? So I'm going to take an acid, which is, let's say I take a hydrochloric acid and it's in aqua solution, right? So what will happen is that this guy is going to create an H ion that will be in aqua solution. And then what happens? The Cl, it will have a negative charge ion. Okay, so we can see that the acid, this is an acid, okay? And since it's an acid, it releases the acid, it releases what? The acid, it releases the H plus ions. Okay, so when they say define an acid according to Arrhenius theory, Arrhenius says that an acid is a substance that forms the H plus ion in water. A substance that produces the hydrogen ions in water is a substance that produces hydrogen ions. In water. Right, the hydrogen ions in water, we are referring to the H plus ion. Let's work on 7.2.1. They say that the table below shows aqueous solution of different substances and each of concentration 1 mole per decimeter cube at a room temperature. Okay, before I answer questions, I'm going to analyze everything on this table. Before I answer, how many marks? 5 marks. So we need to understand the table first, and then we're going to work on working on how to find that 5 marks. So I have the table here. Okay, so this is the table, as you can see. So on this table, I'm going to analyze everything here because it's very important that you guys understand how this goes down. Okay, first things first, we need to identify substances from this table. Let's start with I'm just gonna work out each and every of these substances so that you can understand what is going on. Let me start with the first one. I have a substance of HNO3, or it's HNO3. Okay, HNO3. So the HNO3, what type of substance is this? This is what we call a strong acid. Guys, you already have the table that you need to memorize. Go and find the table where they show you the strong acid and the weak acid, the strong base and the strong acid. The strong acid, you understand? Strong acid and base, weak acid and base. Find that table. You'll see that the HNO3 is a strong acid. So we need to identify all of this. The second one, it's H2SO4. Okay, so H2SO4. So now, since it's the H2SO4, I'm going to say this is sulfuric acid. But now, this sulfuric acid is a strong acid. You can't only say it's a strong acid, but it's a strong diprotic acid. I'm going to explain that. It's a strong diprotic acid. So the reason we are saying this is a strong diprotic acid is that the reason this guy, it has the 2 ionizable H ions. Okay, it has the 2 ionizable H plus ion. So meaning that it can donate it has 2 hydrogen ions available to donate. This one is a strong acid because it can completely ionize in water. Okay, let's work on the next one. The next one is sodium chloride. That's a salt. It's a neutral salt. So the next one, that's sodium chloride. So this is a neutral. It's a neutral salt. Okay, so if this is a neutral salt, I need you to understand how is that salt formed, because we need to go through all these things, then we'll be able to answer the question. So how is this neutral salt formed? It is from what? It is from a strong acid, which is from a strong acid. Okay, from a strong acid, it reacts with a strong base. We're coming to that one. Don't worry, everything will make sense. Right. What about the sodium? What about the NOH? That's the sodium hydroxide. Sodium hydroxide, that's NaOH. This guy here, it's what we call a strong base. This is a strong base. The reason it's a strong base, it produces the OH ions. The OH ions. Okay, what's next? We have the COOH, and this guy, it's a weak, but since it has 2 hydrogen to give away, since it has 2 hydrogen, it's going to be weak diprotic acid. So this will be a weak diprotic acid. Diprotic acid. Okay, so when I look at this guy here, you see this. It has 2 of the acidic H plus ions, and we know that it's weak. Okay, we'll come back to that one, and you'll see after analyzing all these things, it's going to be easy for you to answer your questions. And then now the other one that we're going to have, it's HCO3 minus. This is what we have next on the table. So I'm not going to waste time on this one. This is an ampholyte. The reason you are saying that this is an ampholyte is that it can act as an acid or a base. So an ampholyte is a substance that can act as an acid or a base. 100%. Okay, so what do we have? We still have three more substances to analyze. The next one is what we call the MgOH. This one, because of the H, is going to be the base, né? Right. This is what we call, this is a metal hydroxide, okay? So we're going to say it's a base because Mg, that's a metal hydroxide. So it's a base and it's a metal hydroxide. Then we have the NH3. This one, it's a weak base. Right, it's a weak base. And then we know that is the one that accepts. So this one, it accepts the H plus ion. Okay. Right. Do we have another one? Yes, we do. The last one. This one, it's what we call a partial ionization. So it's going to be a weak acid. So the CH3, if you check on your table, the CH3 is going to be under a weak acid. So ladies and gents, now that you know all these things, it's going to be easy for you to answer the questions. Let's see what we have on the question. They say, identify from the table and write down the formula for a weak diprotic acid. Okay, so I'm going to help you, because now when they say a weak diprotic acid, already we know that we said a weak diprotic acid is going to be this one. Okay, so the answer is going to be CHOO, but let me help you to get that in an exam. So this is the answer that we need to give them, the COOH2. But let's discuss this thing further and how we're going to arrive to that one. A weak diprotic acid. Let's say you are in an exam and you don't know how to answer this one. This is what you need to do. You need to first, they are looking for a weak diprotic acid. So this is 7.2.1. Now I'm training you how to answer exam questions, how to analyze exam questions. You are looking for a weak diprotic acid. So if they look for a weak, you need to understand the following weights: acid and diprotic. What are these two weights meaning? Weak, oh, I'm sorry, acid and diprotic. Acid, we said the acid, they produce what? The H plus ions, okay? And then the diprotic, they can donate what? They can donate 2 hydrogen ions, right? So example, I can definitely give you the example of diprotic acid. So e.g., for diprotic acid, sulfuric acid, that's diprotic. H2 CO3, that's diprotic. Another example is the COOH, the one that we have on the table. So that is also diprotic. So reason we are saying that these guys are diprotic. Why are we saying that they are diprotic? Because all of these people, they all have 2 acid, they have 2 acidic hydrogen to give away. I hope you guys understand that part. So now when you understand this, they said we now you understand what is a diprotic, you understand what is an acid, right? So and then you're gonna go to your table. You're going to indicate all the acid and all the acid that are diprotic. So I'm gonna go there and indicate all the acid. So I have this guy. Okay, let me do this with a different marker. We need to indicate all the acid. We said NHNO3 is a strong acid, but is not diprotic. Then you move to the next one. H2, that's a strong diprotic acid, is going to be part of the 7.2.1. Then this one is not an acid, the sodium chloride, that's a salt. Then NaOH, that's a base. Then this one is also diprotic acid. Then you keep what is this? You're going to indicate all the ones that are diprotic. So we have 2 of them. Okay, we have 2 of them. After indicating that we have 2 of them, you go back to the question. The question is looking for what? Weak diprotic acid. Then you need to understand the word weak. What is the meaning of weak? Right. So when we say weak, this one, it partially ionized in water. So it partially ionizes in water. So since it partially ionizing on water, therefore the correct answer is CHOH2. Okay. Then because it contains 2 acidic hydrogen and it's weak, this one is weak and it contains 2, then that will be your answer. So the answer for 7.2.1, that's that one. Let's move to 7.2.2. So the next one, they say that a solution with pH of 7, a solution that has the pH of 7. Okay, so I'm just going to start this down here. Step 1, I need you to recall the pH scale. For 7.2.2, recall the pH scale. The pH scale goes like this. I'm going to give you the pH and the meaning of that pH. Okay. Let me give you the pH and the meaning of that pH. Number 1, if the pH is less than 7, if the pH is less than 7, we say that this is acid. If the pH is equals to 7, we say that this is neutral. And if the pH is greater than 7, we say this is a base. Okay, so now that you understand this, the question says that we're going to look for neutral substances. Okay, we have to look for neutral substances. So the question says a solution with a pH of 7. So the one that has pH of 7, it should be neutral. You'll go to your table and identify the ones that are neutral. So the one with the pH of 7 are neutral. So you look for neutral substances, and I'll definitely give you an exam tip. So if you go all this, you'll see that we said the salt is the one that is neutral, right? So the salt is the neutral. So sodium chloride is the one that will have, therefore the answer for that 7.2 is going to be the sodium chloride, NaCl. Okay, so the sodium chloride is formed from what? A strong acid. This guy, the sodium chloride is formed from a strong acid, which is HCl, and a what? A strong base. And a strong base, which is the sodium hydroxide. Okay, so it has approximately pH of 7. So the tip that I'm going to give you is that if you react a strong acid and you take that, you react it with a strong base, the solution will be, you'll get a neutral salt. So you'll get a neutral salt. Right. And neutral salt, they have the pH of 7. That's an exam tip that I want to leave you with. Next question. An ampholyte. So already we know what is an ampholyte. An ampholyte, we said it acts as a base. An ampholyte, it's a substance that can act as an acid, and it also acts as a base. So the answer for that is this one. So when you look at this, the hydrogen carbon, it can donate the H and it can also accept the H. Okay, so I'll definitely go through that with you now. Okay, so to answer this 7.2.3, we are saying that the hydrogen carbon, which is the HCO3, this is the answer. So this guy can act as an acid. So if it acts as an acid, this tells you that I can say the HCO3, it can give away the hydrogen atom. It can definitely give away that hydrogen atom, and it becomes like this. It's going to be the C, okay, the CO3. Since it already have minus charge, now it's losing another one. We're going to say 2 minus. Okay, then when it gives away, we're going to have the what? The H plus ions in a solution. That is when it is acting as an acid. So it can also act as a base. So we also need, guys, I'm preparing you for exam. I'm going to explain why I'm doing all this. Yeah? So it can act as a base. So when it acts as a base, we know that it accepts the H. So acting as a base, this one, it donate, when it acts as an acid, it donate the H plus. And then when it acts as a base, it accepts the H plus. So how can it accept the H plus? So we're going to have that HCO3 minus, it will react with the H plus, then it becomes what? So now it gaining that, so the minus will go away, it becomes H2CO3. I hope you understand that. Therefore, you can see that this is an ampholyte. Since it can do both, an ampholyte. So the shortcut that you can do when in an exam to look at on the table, you're going to go through all those substances on the table. Ask yourself, can it lose a hydrogen? Can it gain a hydrogen? That's a shortcut. Ask yourself, can it lose the H or not or but and can it gain the H? That's how you get an ampholyte from the table. Right, let's move to the next question. 7.2.4, they want us to find on the 7.2.4, they say find the solution which, when neutralized with the COOH, will have a greater than 7, a pH that is greater than 7. This is where learners struggle, and I'm going to go slow on this one. This is going to be very long. I know it's 2 marks, but this is going to be very long. So the solution which, when neutralized with the COOH2, will have a pH greater than that. Let me work out on this question. First thing first, I need us to identify the acid. Okay, so on the first step for 7.2. What was this? 7.2.4. 7.2.4. I'm going to first identify the acid. I'm given that the COOH, right? That's the acid. So this guy here, it's what we call a weak acid. Okay, you still remember we went through all that, né? This is a weak acid. So if this is a weak acid, ask yourself, what happens if a weak acid reacts with a strong base? You take a weak acid, okay? We take a weak acid, we react that with a strong base. What do we get? So the salt is formed. But now, if the salt is formed, what is the type of that salt? It's basic. The type of the salt, it's basic. Therefore, the final pH will be greater than 7. If you still remember, I just gave you the table that you need to understand when it comes to the pH. If the pH is greater than 7, this tells you that the salt will be the basic. Okay, let's go back and continue working on this one. First thing first, we are given the weak acid. We know that from the question they said that a solution when neutralized with the will have a greater. We know that the solution that will have a greater pH, it's when a weak acid, it reacts with a what? With a strong base. Okay, so remember that we need to find, already we know the weak base, the weak acid, it was given, right? The weak acid, it was given, which is this guy. We need to find the strong base. That is what they are looking for. Okay, you go to your table, you identify all possible bases, then you're going to choose the one that we need. Let's go and check the possible bases from the table. You see, if you can analyze this thing, you're going to see that this is not a base. We said it's a strong acid. H2 is a strong diprotic acid. Na, it's a neutral salt. And then NOH, that's a base. Okay, you identify all this one, it's an ampholyte, it can act as an, so I'm just going to leave that for now. This one is a base. The NH3, that's also a base. We are looking for what? A strong, in this table, we are looking for a strong base. What is the strong base? The NOH. Right. So When we do this, we're going to say, to answer this question, the strong base, we know that the strong base is the sodium hydroxide. Okay. Now, you can also do what we call the neutralization. You can do neutralization. Okay, so when you do a neutralization, I'm going to work on that part. I'm going to work on doing the neutralization. Okay, so when I do a neutralization, I can say that the COOH, this guy reacts with the NaOH. It's a weak acid. It reacts with a strong base. So the salt that is formed is basic, and then which gives us a pH that is greater than 7. Therefore, NaO for 7.2, the answer for that is sodium hydroxide. Sodium hydroxide. Okay, let's go and do the last question on that. Oh, let's go to 7.3. 7.3, an unknown acid. We are given that an unknown acid HXY is investigated. And they say that during titration, we have 23.64 centimeter cube of 0.11 mole per decimeter of HXY solution. It neutralized 20 centimeter cube of 0.26 mole per decimeter cube of sodium solution. They want you to calculate the value of X, hence write down the balance equation for this reaction. Okay, you know what I'm going to do? I think it's best if you can, it's fine. I think even if you start with what you are given, analyze what you are given, you're still gonna get the one on this. So I'm going to separate these two things here. I'm going to separate them and say, I need to first analyze what I'm given on that 7.3. Okay, so I'm given the unknown acid. Okay, the unknown acid. And then on this unknown acid, we are given HXY. And then the acid volume, it's given as 23.64 centimeter cube. And then we also have the acid concentration. We are given the acid concentration. So what is the acid concentration? 0.11 mole per decimeter cube. I'll definitely go back and just verify if this is correct. Okay, 23.64, 0.11. Okay, so now we also have the NOH, which is the base, the NOH. For this guy, we have the volume, the NOH volume. It's given as 20 centimeter cube. And then what else do we have? The NOH concentration. So this gives us it was given as 0.26 mole per decimeter cube. I'm just gonna go and just do a quick verification and see if everything is right. Nice. Okay, so now we need to calculate the value of X. That's what we need to do. We need to calculate the value of X. You need to even ask yourself, what is that X? But I'm going to explain that in a minute. And then, so that's the first thing. And then next, we need to balance the equation. Okay, 100%. Let's write the neutralization ratio. That's the first step. That's what I'm going to do first. Okay, let's write the neutralization ratio. Okay, so on the neutralization ratio, we know that the NOH, now you see this NaOH. This one, it will supply us with the OH minus, and then we have the acid. So the acid, it's HXY. Okay, so this means that each acid molecule can release X hydrogen ions. I'm not sure if this makes sense, but let me say this again. This simply means that the each it means each molecule can release X hydrogen ions. So I'm going to write this down here as the formula, then we'll go through that. If I have the HX, Y, it act with the X. So this is the X, NaOH, and this will give us the Na, right? The NaX. So let's say this is the NaXY with the X of H2O. Okay, so this is what happened here. The hydrogen, this hydrogen here, it went to react with the OH in the solution to form water. And then the Na now react with that XY. I hope you understand. So I'm just gonna try to indicate this. So the H, this H, it went to react with the water, and then this sodium, it moved from this point to that point. It becomes the Na, then we have the XY. So this sodium, this part here, the sodium moved to that one. I hope you guys understand how I did my equation here. So what do you notice from this equation? What do you notice? We can notice that the acid, the ratio its acid is to the base ratio. Okay, so if we say the acid is to the base ratio, that's 1 is to X. You see, 1 is to X. I hope you get that part. Okay, so if this is 1 is to X, what is this guy telling you? This means that this is what we must find. Okay, this is what we must find. So we need to calculate the moles of sodium hydroxide. Then we're gonna use the mole ratio for that. Okay, let me quickly work on that. Let me calculate the moles of that sodium hydroxide. Okay, so I'm going to use the formula that says N is equals to the concentration times the volume. We did not convert the volume, but it's fine. I'm just going to work on it. I'm just going to convert the volume down there and see what we get. So the volume for the sodium hydroxide, we said it was given as 20 centimeter. I'm going to divide that by 1,000. The volume becomes 0.20. So this is 0.20 decimeter cubed. That's the volume. So if this is the volume, I can just quickly do my substitution. Say N is equal to C times V, the concentration of sodium hydroxide. It was given as 0.2. You see, when you do the data, it's easy for you to do the substitution. So the concentration is 0.2, 0.26, and then we're going to take this multiplied by the volume of 0.20. Therefore, the number of moles of that sodium hydroxide, the number of moles of NaOH is equals to, we need to multiply the two numbers and see what we get. 0.26, we multiply the 0.20, this is equals to 0.052 mole. So the number of sodium hydroxide, it's 0.052 mole. Okay, so what will be the moles of sodium hydroxide? This will be the moles of sodium hydroxide. Right. So now that you have the moles, I need you to calculate the moles of an acid. You calculate the mole of the acid and also the mole of that base. We already have the mole of the base. We need to calculate the mole of the acid. Okay, for an acid, we need to do the same. What is your volume for the acid? It was given as 23.64 centimeter cube. Therefore, if you divide that by 1,000, what do we get? Since it's 23 and this will be two zeros, 0.0, then 2. You just have to write that the way it is, but it starts with 0.02364. So that will be the volume. So if this is the volume, I'm going to use the number of moles for an acid. It's CV. Do the substitution, the concentration of an acid, it was given as 0.11. So I'm going to take the 0.11, multiply that guy by 0.11, multiply the 0.11 by 0.02364. Then what is that equals to? Let's see. 0.11, it's multiplied by 0.02364. What is that equals to? So I'm just going to write this as 0.00, because 10 to the power negative 3, it tells you that we have 3 zeros, then we put 26. So it's going to be 0.020. It's 0.0. Let me go back there. We said 10 to the power 3. I remember saying 10 to the power 3. So there will be 0.0026. 26, and then this will be mole. Right. So what is this mole for? This mole is for the acid, right? This mole is for the acid. Then let's determine the mole ratio. So we're going to use this to determine the mole ratio. So if you still remember, okay, so the mole ratio goes like this. This is going to be the HXY is to the sodium hydroxide. Okay, the HXY and the sodium hydroxide, that is 1 is to 2. 1 is to 2. So if it's 1, that is 1 is to 2. So it's 1 is to 2. So we know that. Let me write this down. What do we know? We know that the acid, the mole of an acid was 0.026, right? And then the mole of the base, we just found that to be 0.0. I think there were 2 zeros. 0.0, is it 52? Let me just go back and verify something here. Let's remultiply this on the calculator. 0.26 multiplied by 0.20. This is 0.052. But now I feel like maybe let me check the volume. The volume was 20 centimeters. So how come we have this as 0.2 as in like it was 200 centimeters? Okay, let me just work on fixing that. So this was 20 divided by 100. I know 0.2 is when it's 200. Ne? This should be 0.02, 0.02, not 0.2, 0.02. So I'm going to fix this guy here. The volume is 0.02. Let's quickly write that. The volume 0.02, which makes this one to be 0.02. That's what we're going to substitute that. This will make this one to be 0.0052. Let me quickly confirm of that. 0.26. Please don't make the same mistakes in an exam. Multiplied by 0.02, which gives us an answer of 0.0052. Okay, so this is 0.0052. All right. And then this is what we have. And look at what we have. This is what we know. So what is the ratio here? What will be the ratio? We know that the ratio will go like this. The one for the acid, which is 0, okay, 0, wait. Let me explain how we got to that part, okay? So this is 0.026 is 2, 0.0052, okay? Then you divide by the small one, which is 0.026. No, I'm going to divide both sides by this 0.026, divide that one by 0.026. This gives us 1 is 2 when you divide the 2. So let me quickly verify that on the calculator. So this will be 0.0052 divided by 0.026. This gives us 0. Wait. I don't know why I keep messing up the twos that I have. It's 0.052, not 0.002. So this gives us 2. Ne? I'm very sorry. You can also try and fix that on your side. Ne? So we don't need a 0 there. We don't need a 0 there. Then now you understand how I got the ratio of 1:2. So if the ratio of 1:2, what is this telling you? So this tells you that x is 2. So the x in front of that the sodium is 2. So the ratio we said is 1:x. Now we have 1:2. So the x is 2. That's easy. That's how easy the question is. And then now to answer the last part of the question, they said you must also verify, balance the equation. Let me balance the equation. So to balance the equation, we know that x is equals to 2. Therefore, the acid becomes H2Y. So I'm going to rewrite the equation. Where there's x, we just put 2. So the final answer when you balance the equation, where there's x, we just put 2. This will be H2Y plus 2 NaOH. And this gives us sodium 2Y plus 2H2O. So this is the equation. And now the equation is balanced. I can also even rewrite the equation down here. This is H2Y, which is in aqua solution. It reacts with 2 sodium hydroxide, which is also in aqua solution. This gives us the Na2 Y in aqueous solution, then plus water, which will be in liquid state. 2H2O in liquid state. Okay, and that's it for this question. I think this was the last question. Please tell me this is the last question for 7. No, we still have a 9-mark question. Wow, I'm not happy about that. Okay, so I say we still have 7.4, but it's fine. Let me do the 7.4. If you don't see the 7.4 now, just know that it's somewhere in this lesson. So we'll definitely work on this. Okay, so you know what I need you to do? I need you to open this question paper in a different device. When I work out on this question, you can also be like looking on the question. In an experiment, 1.5 gram of a powdered impure calcium carbonate sample is reacted with 200 centimeter cube of a 0.15 mole per decimeter cube of hydrochloric acid solution. So the balanced chemical equation is given, and all the CO2 formed, they escape the solution. The resulting solution has the pH of 1.61 and the volume of that 200 centimeter cube. They want you to assume that all the CO3, the calcium carbonate in the impure samples reacted with the hydrochloric acid, and none of them impurities reacted. Okay, they want you to calculate the mass of the impurities present in the 1.5 grams sample of the impure calcium carbonate. Okay, let me work on this question. Please make sure that you open the question on the different question paper, different device. I'm sorry. So now, what are you given? You need to first focus on what we are given to answer this 7.4. We are given the mass of the impure sample, okay? We have the mass of the impure sample, and it was the mass of the impure sample. It's given as 1.5 gram. We also have the volume of, let me say V, of the volume of the HCl, the hydrochloric acid. It's given as 200 centimeter cube. And we also have the concentration, C for concentration of that hydrochloric acid. It's given as 0.15 mole per decimeter cube. Okay, so next thing, we have the balance equation and the final pH. The pH is 0.16, not 0.16, but 1.61. So the pH, that would be 1.16, 1.61. Okay. Right, guys, I don't know what's the issue with my SP pen. All right, so now from this, I'm just gonna first look at what I need. This is what I'm given, and then you need to ask yourself, what do you need from this question? What they want you to do? They need the mass of the impurities, okay? Okay, so now, what is the big idea on this question? What is the big idea? So I'm still trying to analyze the question, okay? The big idea is that we have initially, right, the HCl added, okay? And then some of that, so this is 0.1, this is 0.2. Some HCl, they reacted with the calcium carbonate. Okay, then 0.3, is that some of that HCl, they remain in excess. That's what you need to understand. Then you'll see everything will be easy for you. Then the formal pH, the formal pH tells us exactly how much HCl left. So the formal pH, it tells us how much of HCl left. You see, with this information, the information that I just gave you, like in under the big idea, we can then from that we can find number one. We can find the HCl reacted, and then we can find the calcium carbonate reacted, and we can also find the pure, but we can find the pure COC3 mass, and we can also use that to find the impurity mass. So I'm going to take you guys step by step on how to answer this, the impurity mass. Why? Number one, step one, we said we're going to find the HCl reacted, or let's just rather say, let's first calculate the initial moles of HCl. That is one. Calculate the initial mole of HCl. So to do that, to calculate the initial mole of HCl, I know that if we go back up, what was given, the volume of the HCl is 200 centimeter cube. The concentration is 0.15. So I'm going to use that information by using the formula. The number of moles is equal to C times B. But look at this. The concentration is given as 0.15 mole per decimeter cube. And we have the, what is this? The volume, it was given as 200. I'm going to divide that. This becomes 0. This will be 0. If we divide the 20, the 2, what's that? The 200, right? It becomes 0.2 if we divide that. So this will be 0.2 decimeter cube. Right, so the number of moles becomes the 0.15, which is the concentration, multiplied by the volume of 0.2. Then the number of moles becomes, you just have to multiply these two guys and see what we get. So the 0.15, it's multiplied by 0.2, which gives us 0.03 mole. So initially, HCl start with 0.03 mole. Okay, so I think it's best if we definitely highlight this partner. So initially, I'll say the HCl, it has the number of moles of that HCl to be 0.03. And this is something that we definitely need to highlight for upcoming steps. Right, what's next? We need to use the pH to find the H plus concentration, okay? So on this next step, I'm going to use the pH, number 2. Use the pH to find what? To find the H plus concentration. Okay, so when I use the pH, remember the formula for pH, it's equal to negative the log the concentration of H plus, and then therefore this tells you that the concentration of that H plus, if you still remember how the log, it will be 10 to the power negative the pH. What is the pH? It was given as 1.16. So this will be negative 1.61. So the concentration, you just have to move from this and write it in that form. Okay, that's the formula. That's how it works. So this will give us the concentration of what? The concentration. Remember this big brackets, it indicates the concentration of the hydrogen ion. It will be 0. Let me go punch that on the calculator and see what I get. 10 to the power negative 1.61. This gives us 0.245 if we round it off. Let me just get some help. Mode set up, switch to 3 decimal place, 0.25. We can get that 0.025. 0.025. It is 0.025 decimeter cube. So this is the concentration, and I'll definitely highlight that for upcoming steps. Okay. Right. So now that you have the concentration of the H plus, you can find the moles of the HC remaining. Okay. So we're going to calculate moles of that HCl remaining. Okay, let me quickly work on that. So HCl is strong. Okay, HCl is a strong, and then if it's a strong, this tells you that the concentration of the HCl, it will be equal to the concentration of the H plus ions, right? So the number of moles will be the concentration times V, and you do the substitution. We know that we are saying that these two will have equal concentration. So I'm just going to substitute that at 0.025, which is what we just calculated now as the concentration of the H plus ions. So I'm just going to substitute that, and the volume, we still remember the volume is 0.2, right? And then multiply the two. Therefore, the answer that you get, you'll find the number of moles that are remaining for that HCl. So this will give us the remaining HCl. So let's find that by putting that on the calculator and see what is that equals to. So this is 0.025. This is multiplied by 0.2. This gives us 0.004. Let me just shift 9, because now you see when I run off, I'm going to have problems. Okay, 0.0, we still get something different. So this will be 0.629. 0.005. Okay, so this doesn't change anything. Okay, so I think we made, why did we run off this number? Let me just go back and say 10 to the power negative. I don't want to run off this 1.161161. This gives me 0.24547. I don't want to round it off. So if I don't want to round it off, I'll multiply that by the 0.2, which gives us 0.049. Even that one, we don't have to round it off. Ne? So it's going to be 0.0491 what mole. Okay, right. So this is the HCl remaining, and then we need to calculate the HCl that reacted. I hope that makes sense. We know the one that is remaining. Therefore, on this step, the next step, we need to calculate the HCl that reacted. Right, so when we do the one that reacted, remember initially, we started with what? Initially, we said that the number of moles for that HCl, the number of moles for HCl, it was, if I still remember, 0.3 something. Let me see. We started with initially, we started with 0.03, right? So initially, we start with 0.03. And then what is remaining? We are remaining with the number of moles of HCl remaining, that's 0.00491 blah blah blah. So looking at this two, we know what we started with, we know with what's left. So we need to find reacted. We can say that the number of moles reacted, we take that 0.03, we minus the 0.00491 blah blah. So I'm just going to take the 0.3 and minus answer. So I'm going to say 0.03. I'm going to minus answer. This gives me 0.2509. So I'm just going to write that down. So the number of moles reacted, that's 0.02509 mole. So that is the number of moles reacted. So now that you have the number of moles reacted for the sodium chloride, you can go to number 5. Step 5, that's when you can calculate the number of moles of the CaCO3 that reacted. Okay? I know there's too much steps here. Né? Calculate the moles of the CaCO3 that's reacted. So look at this. We were given an equation. From the equation, we were given that the CaCO3 plus 2HCl. I'm just going to go back up. This is the equation that I'm referring to. So what is the ratio? The ratio is 1:2. So I'm going to use this ratio to find the number of moles for that one. So the ratio, R for ratio, that's 1:2. So let me quickly work on that. So if 1:2, the number of moles should be half of that. The number of moles of this one should be half of that. So the number of moles for that CaCO3, it will be half the number of moles of that, the number of moles of HCl that reacted. So it's going to be half of 0.02509 mole, blah blah blah, and then everything. Okay, already I have the half there. And what do you get? Just gonna go to my calculator and say this is divided by 2, because it's half, which gives us 0.0125. This is 0.012545 mole. So this is the number of moles of what? NO reacted. So for the CaCO3 reacted, it's equals to 0.0125. It's 12545 mole. So guys, you can also write these steps down. Try to analyze the step, move with these steps. You can do them step by step. Right. So I'm going to convert this number of moles to mass. You see the one, this number of moles. I'm going to use this number of moles and convert it to mass, because if you can remember from the question, they want the mass of the impurity present in what? In this. So already we have the number of moles. Now let's convert that to the mass. Okay. So I'm going to convert the moles, the number of moles of the CaCO3 reacted to mass. And how can we do that? So remember the formula for mass, N is equals to, the formula for mass, it's N is equals to the smaller m over the big M. Therefore, the number of moles will be, okay, let me just make the mass subject of the formula. Therefore, the mass, the small m will be the number of moles times the molar mass. So I need to find the molar mass of that calcium carbonate. So we're going to need a periodic table for this one. We need to find the molar mass of calcium carbonate. So what is that equals to? So I'll go to my periodic table at the back of the table. And first, let me start with what? Should I rotate? No, I'm not going to rotate this. I'm going to start with the CA. I think I can even find it when it's like this. The CA is 40. So that's my 40. I'm going to add the 40 with the, we need 4C, carbon. The carbon, that's 12. We're going to add 12. That's 40 plus 12. Then the last one is oxygen, which is 16. But remember, it's the 16 should be multiplied by 3 because it's O3. So this will be 40 plus 12 plus 16 times 3. Then I'm going to punch that on the calculator to find the molar mass of this. What will be the molar mass? So this will be 40 plus 12 plus into 16 times 3. Close the bracket. This gives us 100 grams. I'm very sorry about that. Let me just try and... This gives us 100, right? 100 grams per mole. That's the molar mass. So this is 100 grams per mole. So since I have the molar mass, the mass will be the number of moles, which is the one that reacted. It's 0.0121545 multiplied by 100. This will give us the mass. And what is the mass equals to? So I think I just have to punch the 100, multiply the 100 by the 0.012545 and see what we get. We get the number of moles and the mass as 1.2545. Okay, this is where we're going to do the most interesting part. The mass is going to be 1.2545 grams. Okay, so if you look at this, this is the pure mass. Okay, this is your pure mass, the pure mass. That's the pure mass. So we need to calculate the impurities. Okay, so to calculate the impurities, guys, I don't have much space for this question. So I'm just going to try and squeeze it somewhere here. So on step, that was, if this is step 5, this will be step 6. Né? Okay, so on step 6, I'm going to calculate the impurities. So I'm going to calculate the impurities. Okay, so to calculate the impurities, we're going to take the sample mass. Remember, we were given the sample mass, which was 1.61, and then we have the pure mass. And what is the pure mass equals to? If it's even the pure, it's equals to 1.255 if I round it off, right? Then the impurities, we take one we started with. This was the sample. I'm sorry, guys. It's 1.5 from the statement, not 1.61. So if I still remember from the statement, let me just quickly go back up to that question 7. It was given the set the impurities present of the impure. It's 1.5, not 1. That's 1.5. So I'm going to use that 1.5. This is 1.51. Oh, it's just 1.5. So you're going to take the 1.5. So the final answer for this problem You take the 1.5, the impurities, you take that 1.5 grams, you minus that with 1.255. The answer that you get is what they are looking for, is the mass impurities. Okay, 1.5, 1.5 minus answer. This gives us the final answer of 2.45. Or if we round it off, it's 2.46. I don't know, but I'm just gonna leave it at 2.5 now. So it's 2.0.245 blah 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 grams. So this is the final answer. Wow, that was a very long problem. But that's it for this one. This is where you can stop answering that 7.4. That was too much work, but the mark allocation is 9. So even the mark allocation tells you. But what I need you guys to do, I think it's best if I drop this solution, the link for this solution, just in case if you want to go through the solution. I can definitely drop the link where you guys can go and analyze the solution. It's fine. I'll try to drop the link on the comment section or on the description.